So let us welcome now for our next session, Mr. Ulrich Studer, Business Development Manager, HKO Worldwide. He would be presenting on topic, stop or delay the thermal propagation of lithium ion batteries.
Thank you very much. Warm welcome here to my presentation from Saint-Gobain on the battery show here on the second edition. And I will present you our solutions against the thermal runaway. We heard a lot about today from thermal runaway, and I will show you what can we do. My presentation structure is the introduction and location of our production. Then I will inform you about the thermal runaway and the thermal propagation tests we have done in the last years. And I will show you a few use cases of our solutions. Let's start short with a video, what we are doing at our HKO. And trust the experts, that's our headline. And as you can see, we have thermal insulation and EV battery protection. We are a German supplier with facilities in Germany, United States, and Mexico. We make co-development, R&D, and innovation. Our use cases in the battery, it's between the cells to stop or delay the thermal runaway, over the module to protect the people in the car, under the cells and the battery management system and also outside walls, filtration of the gases and the particles, and last but not least, vending shield for controlled pressure release. Saint-Gobain, short information about us. Last year we have $47 billion of sales on 945 sites with 160,000 employees in 76 countries. Our purpose is making the world a better home. Our international presence for this product group for the battery in the Adfors world, it's in Europe, we have 2 factories in Germany and 2 factories in North America, in Dublin, Georgia, and in Tlaxcala, Mexico. In Asia, we are in Bangalore. We have a facility where we can die cut the pieces for the Indian demands. Our worldwide innovation capabilities is split in 8 centers, 1 here in Chennai in India, 1 in Shanghai, China, 1 in Germany, 3 in France, and 2 in America and United States and Brazil. Now let's come to short videos from our thermal runaway tests. And first I will show you the video from Herzogenrath team Saint-Gobain Research on ZSW in Ulm, where we explode pouch cells. And as you can see it here, the explosion of a pouch cell is not directed. It can go in each direction. And that's very difficult to protect. And if the material between the cells is not good enough, in this case, in this test, after 4 minutes, the second cell starts to burn. And you see it's a lot of fire and also a lot of risk for the people inside on the car. And our target, it's no TP. That means no thermal propagation. Now the second video I show you, it's a prismatic cell with the same design with our material between the cells. And as you can see it here, the second cell is not damaged. We stopped the thermal runaway with our material multi-layer with the brand DefensorFlex type ML25. Now you see our material in the factory of our customer. We are a tier 1. We supply directly to the OEM. And this material, what you see now, It's validated since 2021. Since 4 years, our customer used the material, and you can see it here on this video, to protect the battery management system, and also in the middle to protect the bus bar against the risk of thermal runaway, and also in the top of the venting areas of the modules to protect the people in the car. And this material is available worldwide. We have cutting units in Mexico, here in Bangalore, and also in Europe. And the second material is the ML31, what you see in the middle on the bus bar. It's a basic material, it's a woven. And the full supply chain we have is in the Saint-Gobain. We make the fibers, we make the impregnation, we make the lamination. Now I will explain a little bit more about our use cases. First, cell-to-cell protection compression pad. With our fiber-based products between the cells, can be prismatic, can be pouch, can be cylindrical. We can stop the thermal runaway because we have a low lambda with good insulation properties and a high temperature resistance. The temperature resistance of our fibers is over 1000 degrees C. And in combination with a mica layer on both sides, we have a balanced product. The fire can come from both sides. And we have over 10 kilovolt electrical resistance. The second application is for the modules. And in the top of the modules, under the lid, our material is validated since 2021. And now this next cell generation, we are also nominated from the customer to supply the pieces. But in the battery world, everything is moving very fast, and we work also on new developments for the next generation. On the pack level, we have different applications, as you see it in the video, to protect the battery management system, to protect module to module. We are nominated last year from the second OEM, and also to protect the module from the outside burdens in case of fire on the street. Then a very new development is a filter material, where we start in the last year, where we have materials what is not burnable, not burnable and high resistant because it is inorganic. And this material is designed in the inside of the battery to stop the particles in case of thermal runaway, and the hot gases can go out. And last but not least, the venting. It's a very difficult system, and we have developed together with a third OEM the venting shield, and this venting shield protects the neighboring cell in case of thermal runaway. I will explain in the end of this presentation a little bit more about this. One very important thing is to simulate this phenomenon, because the thermal runaway is very difficult to simulate, and for this we have in our SGR centers a lot of characterizations to learn how it works. And first I show you the simulation from a 6-cell stack without material between the cells. And as you can see it here in fast speed, only 4 minutes, 30 seconds, the full module is burned. And now you can see no thermal propagation, the same system with our material between the cells. One cell exploded, go to 800, 1000 degrees C, and the neighboring cell is below the trigger temperature. And that's very important to have no thermal runaway on the neighboring cells. We stop it. For this application, actually, we have 6 different products with the delivery thickness starting from 3 to 6, can be compressed to 50% to have the right pressure in the beginning of life and also in the end of life, in the end of the car. Use case number 2 is under the lid. And as you can see it here on the red line in the simulation, without our material, it needs only a few seconds, and the aluminum lid can be melted. And this is one of the reasons that more and more development goes in the direction that you need fire protection under the lid to protect the people. With our material, you can see it here on the blue line, after 30 seconds to be outside below the needed temperature. Use case 3 is in the module area. First of all, we have to protect the battery management system, because if the battery management system failed, the complete batteries failed. That's very important that the system is working. And for this application, we have different materials, start from 1 millimeter to 3 to 4, with a high resistance against the heat and the particles. Use case 2 is against the fire from the street, because the ECE R100 revision 3 say you need 70 seconds resistance against the fire from the street. Use case 3.3 is between the modules. We are validated since last year with the first OEM, with the material ML28, with only 1,360 grams. That's also one advantage of our materials. We have low area weights because we have good insulation properties. Use case number 4, the filtration. You can see it here as a green layer. It's installed in the front of the burst disc to stop the particles and also to reduce the toxic gases. Last but not least, the venting shield. As you can see it here in this drawing, one cell eject the particles, and here you see the effect. The materials open the hole. This hole creates the path for the particles and the gas stream, and the neighboring cell is protected from the top. Thank you for your time and your interest. Please visit us in hall number 1 on our booth B08. Our team would be happy to welcome you. Thank you.
Thank you, Mr. Ulrich.